Hello everyone, this is Shatrupa and in today's video we will be looking into Infosys previous year question. Before we dive into the question, I would recommend you guys to check out the description for the live batches that we are running. So if you feel like you're interested, that would give you some extra help. Do not forget to enroll on those courses. Second, don't forget to like, share and follow Campus Monk for more videos. Now let's get started without wasting much time. So as we know in Infosys, we'll be having four questions, right? Easy, medium, hard, and complex, right? And you will have to solve them. And at least you need to get 3 out of 4 correct in order to qualify for the next round, right? So, in order to qualify, you have to at least get easy, medium, and hard correct, if not the complex one. Okay. Otherwise, if you can definitely solve these three, completely up to you. Like whatever question you see and you choose, that is up to you. But remember, you have to do at least 3 questions out of for total 4. And for that, you will be given a total time of 3 hours. Okay. The next thing is very important that remember here in Infosys you just have to write the function, okay, which makes it easy in a way, but the questions will be a little difficult, it will be hard. So in order to figuring it out that you can not always do brute force, okay. So for these questions somewhere you have to optimize the code, so it is completely up to you how you choose to optimize it. All right. So it can just be one step better than the brute force. It can be 3 steps ahead of the brute force. So it is completely up to you. And just to clear one of your doubt that a lot of people think that n square is a bad time complexity. It is not. When it comes to questions that are complex like graphs and trees and all of that, it is not a bad time complexity. You can definitely have questions which has a time complexity of n square and it is not bad, okay, and it is an optimized code. So don't think about it in a way that, oh, it is n square, then definitely this is not a good approach. No. Okay. So not always that n square is a bad time complexity. Sometimes you will get worse time complexities like n cube, n to the power 5, 6, and all of that. So if you're bringing that down to n cube, you are optimizing the code. Okay. So keep this in mind. I just wanted to clarify that. And here you definitely have to just write the function. So you basically get it in lead code pattern. So the main function and the inputs are already taken up for you. You just have to match the function according to the code description or whatever is given over there in the question and just write in the code. All right. So this was a brief introduction about what will happen on an Infosys test. It has I mean, I would not say the easy question is absolutely easy. At the same time, I will not say that the complex one means extremely complex, but yeah, it is kind of time consuming. It is going to take some time because you need to think about those questions. Okay. So now we are going to look into the question and we will see, like, we'll try to decode from it what it is trying to say. Okay. Honestly, this would be the first time that I'm going to run on those questions, so we'll see and we'll try to figure it out how those things are going to work. Also, I will be coding it for you guys in C++, Java, and Python. You can choose whichever one you feel you're comfortable in, and you can pick up that code. Okay. So if you have any other code, definitely give that code a try as well. Okay. Otherwise, you can stick to whatever I give, or whatever you see. You can always take a screenshot and try getting that further optimized, maybe with the help of chat gpt, claude, or whatever you want to use. All right. Okay. So let's get started with the question. So the first question, this is in Campus Monk's own platform that we use for coding. So we'll read the question first, try to understand what the input format is, try to understand what the question is trying to tell us, and then we are going to see how we can code. Okay. So it says that given an array A of length n and an integer k, you must perform the following operation exactly k times. So what are the operation? It is mentioned over here. Okay. So the first one is to choose two indices I, j and swap A of I with A of j. Find the maximum possible maximum subarray sum. Okay. So you need to find the maximum subarray sum, but if you have a k value, you need to make sure that you swap that many times, exactly that many times. Okay. And then you find the maximum subarray sum. Okay. So it is completely a decision to be made that whether you should swap the numbers and then do the sum or not, because you need to return maximum. So in that case, you always your subarray, the values within the subarray must sum up to a maximum number after swapping. Okay. But if in case you see, oh, this is not helpful, this is not working, in that case you will not swap it. Okay. So that is completely a choice to be made while coding. Then it says that after performing the above operation exactly k times. I mentioned this, alright? Note that swapping the same pair again is allowed but useless. Obviously, like I swap 1 and with 2 and then again I'm trying to swap that 1 and 2 again. So again, I need maximum. So obviously, if I'm choosing to swap 1 with 2, I'm going to choose 2 every single time, right? Because I want it to be maximum. So it is absolutely useless if I say that I'm going to swap it again. Does not make sense. Okay. A double swap cancels out. Therefore, performing exactly k swaps is equivalent at most k useful swap. Okay. Another thing they are trying to point out here is, suppose I have one in my subarray, okay, and outside my subarray I have two. So if I bring in this two, definitely it will give me more sum than one, correct? So in like I swapped it, okay, I did this, I took one out and I bought in two. Okay. So now this is fair enough. My subarray inside, like the subarray has better sum than the numbers outside, which is obvious. Now again, if I choose to swap that same pair, okay, what will happen? Again, this one will go inside and two will be outside, correct? So it became the initial state. Did it make any sense? It did not. Why? Again, you are at a loss. So if you are swapping it in and again swapping it out, right, so the effect is cancelling off. Again, your sum is reduced. Okay, so do not do that. So swapping here is a vital condition. You need to keep that in mind. All right, next let's read the question. Okay, so that is the question. So basically, you have to swap the number such that every time that you swap, like your subarray must generate a maximum sum. Okay, and you can only swap for k many times. Then it says the input format. The first line contains integer n denoting the size of the array. The next line contains the integer k denoting the number of swap. Each line I of the n subsequent line contains integer describing a of I. Okay, so this one is n, this is k, and these three are the array elements. All right, fair enough. And this is your output. Okay, all right. Are they the same value? No. Okay, so the array are different. Okay, okay. So let's just understand. Okay, so what it says is that you are given a list. Okay, so you are given a list of numbers and you are basically allowed. So suppose say I have these list of numbers. Okay, and I am allowed to swap any two numbers. It can be 1 2, it can be 2 3, it can be anything. Okay, up to k times. Okay, so there will be a k value, say 1. Okay, up to times. So meaning that swapping is basically exchanging that position. So k times means, so tell me which subarray will generate me or yield more value. Now suppose I choose this subarray. Okay, this is my internal subarray. I have 1 comma 2 and outside I have the number 3. So do I choose to swap 1 with 3 or do I choose to swap 2 with 3? If I choose 2 with 3, then my sum will become 1 plus 3. But if I swap 1 with 3, then my sum will be 3 plus 2. So which is greater? This is 4, this is 5. Definitely this, right? So what will I do? I'm going to swap 1 with 3. Okay, and I can do exactly one swapping. So that is done over here. Okay, so this is the thing. So after you swap, then you look at the list and find the subarray or the chunk that exactly stretches the like they should, like subarray is a continuous thing. Okay, it cannot be discontinuous. So they exactly add up to become the biggest number, whatever it is. Okay, so similarly you will say, then what if I choose this chunk or this subarray? Fair enough, that is the biggest in itself, right? The sum does not change, so you can return either this or you can return either this. It nowhere says that you have to return all. It just says that the sum has to be maximum. So the sum you are returning, right? So you return 3 plus 2 or 2 plus 3, it won't affect the output because you are returning 5. And in both the cases, the sum is going to add up to 5. Okay. So basically, your job is to figure out the biggest possible total that you could get if you are allowed to rearrange these things within the subarray, making sure that you take k amount of swap. Okay. That is the overall thing. Okay. So we'll first note down few things that we could do. Okay. So what is the first thing that we can do? First, like talking thinking about, forget brute force, forget everything. Like in just in general, if I give you a bunch of or a list of numbers, how will you figure that out? The first thing would be to try every possible subarray. Try every subarray. Correct. So in this case, what you will do is to have a starting point and an end point for that subarray. Okay. So suppose the starting point is at position 1. Okay. So like here. Suppose this example only. So this is position 0, 1, 2. So these are the index, and suppose position 1. You are starting here. Okay. And suppose what is the first subarray? It is 1 only. Okay. Then you will take another starting point and another end point. Correct. So two things. You need to have the starting point and the ending point. Correct. So if the array is 1, 2, 3, what are your subarrays? It will be 1, then it will be 1, 2, then it will be 2, 3, then it will be 1, 2, 3. Correct. So all of them, and even individually 2 and individually 3. So we'll every possible chunk. Okay. Now for every subarray or every chunk of element that you have picked up from the start to the end, you need to question one thing, that can I make this subarray better if I swap it? Because I have some swap value. Okay. Suppose, okay, the first vital condition would be to check if k is equal to 0. If k is equal to 0, then you cannot swap. So whatever chunk you have or whatever subarray you have, you need to find just the maximum of the sum of those subarrays. That's it. Okay. But if you have some k value given, okay, k is equal to 1, k is equal to 2, 5, whatever. So for that many number of swap, you need to make sure that this works. So you, in that case, you need to think that whether the subarray, the addition of these elements in the subarray, will it be any better if I swap it with any element that is outside this subarray, okay, outside this current subarray. Okay. So if a number outside is bigger than the number inside, then it is always worth swapping. Okay. Like here we saw. Okay. Right. Like here. Got it? So remember that. So the next part, what is the point 2 then? It is to decide if swapping is important. If swap is not important but needed. Okay. So why am I writing these points down? So I need to put exactly these point in my code. Okay. So I'm just trying to figure it out in normal term. Okay. And one more thing, your elements can also be negative. Okay. So if your element is negative, then definitely make sure to swap it. Why? Because negative element is always less, going to make your sum less compared to a positive element. Correct? If I have 5 minus 5 and outside I have 1, okay, so I'm going to remove this minus 5, replace it with 1. Why? Because then my sum will be 6. Otherwise, if I keep this minus 5, my sum will be 0. Okay. So if it's a negative number, try removing it. Okay. Point number 3. Sorry, point number 2. Next step should be that do this swap as many as times it is allowed. Okay. Do not forget the k times limit. Okay. In order to just swap it, don't do it blindly. Okay. So if swapping wouldn't help anymore, you don't have to do it. Okay. Even if you have k times, it is okay. But if it's not helping, suppose here in this case, okay, imagine, sorry, suppose here I had 3, 1, and 2. Okay, let's not do this. Let's just keep it as it is. Just okay. Suppose this was the thing. Okay, now this is my subarray 3 comma 2, and I have 1 outside. Okay, just for the sake that I have k is equal to 1, I necessarily don't have to swap. Why? Because if I swap, just think about it. If I replace 2 with 1, okay, so what will it be? 3 plus 1? Right. So that is equal to 4. But if I don't swap, I have k times of swap, but I don't have to swap, right? It is not mandatory. Why? Because the end goal is to get the maximum sum. I need max sum. So I don't care how that comes, even if I have number of swap, but that is unnecessary. I am not going to swap it. Okay. Keep that in mind. Okay. You have k times limit, but swap only when needed. Okay. Don't do the swap unnecessarily. Okay. Fourth track is to keep the sum of the best total. Okay. Whatever is your best total of every, for every subarray. Okay. For every subarray, you need to keep that. And this is your answer. Okay, don't forget that. Okay. Another thing that I have already mentioned, but I will repeat that suppose if your k is equal to 0, that means there is no swap. In that case, step 2 and 3 will never get executed. Okay, step 2 and step 3 will never get executed because they are the swapping steps. Okay, so you need to keep that also in mind. So that will never get executed. All right, let's look into a question. Let me just put this down as well. Step 2 and 3 will never get executed. Okay. So I think I have made my points very clear and very vivid because this is the best explanation that I could give it to you. Okay. I put it down here in words. Now, if you want, you can pause the video, try implementing it on yourself before we actually jump onto the dry run or we jump onto the code. Okay. So you can try doing it yourself right now. Okay. Otherwise, let's take a look. Okay. So say your n is equal to 3 and your k value is equal to 0. Okay. And suppose your array elements are given as 5, -1, and 5. Okay. Now, what are you going to check? We'll check for every possible subarray, right? That was our first point. So, what are the possible subarrays over here? Okay, let's consider it is 5. Correct. Then we have 5, comma -1, right? And then we have 5, -1, and 5. Correct. Then we have just -1. Then we have -1 and 5. And finally, we have 5. Okay. Now, let's do the sum. What is the sum over here? Just 5. What is the sum over here? 4. What is the sum over here? 9. Here, what is the sum? It is -1. Here, it is 4. And here, it is 5. Okay. Now, you must be wondering, I did not swap. Yeah, I did not because k is equal to 0. So, I cannot swap. Now, what is my answer then? My best or biggest sum will be this. Okay. Since I cannot swap, my k is equal to 0. So, what did I have to do? I had to skip step 2 and 3. So, these two were only swapping steps. So, I skipped it. So, what I kept doing? I kept the best total for every subarray. I kept keeping totals for every subarray. This one was the maximum. So, I will return this. Okay. All right. Now, I will give you another question. Try this as a dry run. Suppose n is equal to 3, k is equal to 0. Let's take a is equal to say 1, -5, and 2. Okay. Pause the video and give this dry run a time. Chalo, I will give you 30 seconds. Tell me what is the maximum best solution for this one and put it down in the comments so we'll see how many of you get it right. Chalo, your 30 seconds starts now. Okay. So if I think about the subarray, okay, what will be my subarray? It will be 1. Then I'll have 1 comma -5. Then I'll have 1 comma -5 comma 2. Then I'll have -5. Then I'll have -5 comma 2. And finally I will have just 2. Correct. So here my sum is 1. Here it is -4. Here it is -2. Here it is -5. Here it is -3. Here it is 2. So again, what is my maximum then? My maximum is here, this one. Okay, so I'm going to return this. Again, why no swap? Because k is equal to 0. So I don't have to swap. Okay, now let's try an example where we have a k value. Okay, so say n is equal to k, sorry, n is equal to 3, k is equal to 1, and suppose a is equal to same. Let's take the same thing for here. Okay, now here you will have what were your subarrays? These were your subarrays, right? Let's write it down. It was 1. Then I have okay. Then I have 1 comma -5. Then I have let's take the complete array. 1 minus 5, 2. Then I have minus 5. Then I have minus 5 comma 2. Then I have just 2. Okay. Now here you got a sum of 2 that was maximum. Correct. Now let's see, with one swap, can we maximize, like will we get a number that is bigger than this two? Because here we had k swaps. Okay, these are two different examples. Understand that only our array is same, but our k value is different. Okay, so according to the question, if we have a chance to swap a number with a bigger number, our sum must be bigger, right? So let's see this. Okay, so here the sum will be 1, correct? Here the sum will be minus 4. Okay, but see that this minus 4 is inside, okay, is small, and outside the chunk what do we have? We have this number, right? 2. Correct, we have this number over here, 2. So can we replace this minus 5, because it is a negative number, can we replace it with 2? Definitely. Then you must be wondering, then outside also can we replace this one with 2? Yes, of course you can replace that one with 2. You know what, I will put it up in a different way, so in a different color pen, so it's easy for you to understand. Okay, all right, so here let's choose the other color. So what is outside for 1? We have minus 5, we have 2, correct? What is outside over here? Just 2. What is outside over here? Nothing. What is outside over here? 1 and 2. What is outside over here? Just 1. What is outside over here? 1 and minus 5, correct? These are outside. Now tell me, if I swap minus 5 with 1, will this sum get better? No, it will get worse. But if I replace 2 with 1, will it make it easier? Yes, it will. So let me use 2. Okay. So what will happen to my sum? It will become 2. So it is at least better than 1. Okay. Now for the next one, tell me, should I remove 1 or should I remove minus 5? I should remove minus 5. What is the reason for removing minus 5? It is a negative number. No matter how much positive number I add to a positive number, if I have a negative number, my sum will get reduced. So what I can do is, instead of removing a positive 1, I will remove negative 1. Okay, so in a way you can say whatever is minimum of the two within this sub array, I'm going to just get rid of that one. Okay, so here my sum will be 3. Right, here there is nothing outside, so we can't replace anything, so we have to bear with it. Our solution will be minus 2. Okay, it will be equal to minus 2. Again here we have minus 5 inside, and outside we have two positive number, but which one will yield more or maximum sum? Definitely if I put 2 inside, because 1 is still less than 2, so I'm going to replace this with 2. Okay, so my sum will become 2. Okay, here which one should I remove? Should I remove minus 5 or should I remove 2? Definitely I'm going to get rid of the negative number if I have any, so I'm going to replace that. I'm going to put 1 in place of minus 5, and I'll keep 2 as it is. Sum will be 3. Okay, then here what do I have inside? I have 2. Is it advisable to replace 2 with 1? No. Why? Because 1 is less than 2, so it will never yield a maximum sum, and minus 5 is much more lesser than 2, so that is also not going to yield, right? So I will keep 2 as it is, and it will be 2. The sum will be 2. Okay, so now tell me, which one is having maximum sum? So here there is 1 3, and here there is 1 3. Now you are not asked to return this, okay, or you are not asked to return this. Okay, you don't have to return subarray, you just need to return the maximum sum, and in both the cases it is just one answer, that is 3. So if you have multiple things, multiple subarrays yielding the same answer, then you don't have to get bothered about that, because the answer is same, right? And you are returning just the sum. So output to this solution should be 3. Okay, okay, so I hope that you have understood this question. Okay, honestly, if you think about the time complexity, it will be around, like, time complexity of this will be big O of n square log n. Okay, so like we will derive this from n square log of, it should be something like this, n plus k log n. Okay, but we can deduce this, because this is going to be a constant, so this value will change to 1, because you have the k value. Suppose either that will be 3, like any integer number, or it will be 0. Here n will always be a natural number, right? So that value is going to get reduced to a constant, and you will have n square here, log n. So it is going to be basically big O of n square log n. Okay, because these two values will always have a number. So like in our question we saw n was 3 and k value was either 0 or 1, so it will be just 3, right? So if I say 3 plus 0 is 3, which is a constant, so for constant we just write 1, right? So it is basically this. Okay, so time complexity is going to be this, the code that I am going to write. Now if you want, you can definitely use your own ideas and improvise this, but honestly this complexity will also be accepted for the code. Okay, so do not worry about that, and your space complexity will be bigger of n. Okay, so let's see the code now. I hope that you have understood this and whatever we have done so far. So it's not that complicated question, but it is slightly tricky when it comes to putting down as a code and all. Okay. Okay. So we'll start with C++ itself. Okay. So that is your question. Let me just select this and we get rid of this. And all right. So we'll start by first is definitely hash include. Okay. Don't worry, I'm going to paste in the comment lines. I will keep explaining, but at the end, I'm going to add in all the comment lines as well. And I'll scroll from top to bottom once so you can see all of the codes. Okay. All right. So it will be bits slash stdc plus plus dot header. Okay. And definitely using namespace std. Okay, so yeah, one more thing, that here you are just supposed to write the function. So for the platform that I'm going to use, I'm going to put everything inside the main function itself, but for you, you cannot use the main function, I guess. Okay, so they always provide you the function name that you have to use, so make sure you use that function name. Okay, do not change that to main. Okay, but since this is a self-designed platform, like it does not have a proper main function, I have to write everything from scratch. So I'm going to put everything inside my main function. Okay. So just keep that in mind, but you're not supposed to write main in the actual test. You will always be provided with a function name. Use that function name. Okay. The first thing, let's declare n and k. Okay. We have the size of the array and we have the whatever the k limit is. Okay, now we have to read both of these, so let's do a c in n and c in k. Now I'm just doing it like this because you don't have to be bothered about any of these are the part of the basic main function which is already written. I will tell you from where you will be bothered, so let me just move through this little fast. Okay, then we'll definitely have the vector int a of size n. Okay, and then we have to loop through each of them, so we'll read those elements. So we'll say int I is equal to 0 and I is less than n and I plus plus. So we can do c in a of I. All right, and then we'll definitely need, like, we need to hold the maximum sum found so far, so we'll always start at the minimum value, right? That is minus infinity. So this is a part of your code, so I'm going to do long, say best, let's keep that as a best total. So I'm going to take that as long min. Okay, so that will basically be your minus infinity if I talk in literal mathematical term. Okay, now we need to loop over every possible what is that called, subarray, right? Every possible chunk. So I'm going to say, suppose now this one is for the left edge. Okay, like you're going to start from the 0th index. Okay, so let me just take L is equal to 0 and L must be less than n and L plus plus. Okay. We also need a multi-set that will keep the elements sorted. Okay, because if they are in an unsorted way, like we saw over here, okay, like this, like this one is also sorted in decreasing order. Like suppose if it is in unsorted way, like this array is unsorted. Okay, so for that case, at times it becomes a little clumsy, so we'll just say multi-set and we'll say int, let's say outside. Now this one is going to basically either insert it or remove it. Okay, so from where will it start? It will start from the start, so we'll do a dot begin all the way till a dot begin plus 1. Okay, and similarly we need to insert the remaining elements into the like from the position, like from this set into the other half, right? We are removing this. So where did it go? So we decided to swap the numbers over here. So we removed one outside and we brought in two. So this removal has to go out. So we need to keep a track of that also. So we'll say outside dot insert, right? So that one got inserted into this outside set. And that will also be a dot begin plus one all the way to a dot end. Okay. So that is what we have. Now, what will be there inside your inside one, like the sub array that you're going to consider? So let's call that also multi-set type int, and let's call that inside. Okay. Now, you are going to simply insert the first element of your array, sub array, into this inside thing, right? So you will say inside dot insert, and what will you insert? A of L. Okay. Now you need to keep a track of the running sum of that inside subarray, right? So we'll say long, long. Now I'm taking it to be long, long because I don't know how many numbers my array will have. So that should be equal to basically like what will you initialize that with? The first element of A, okay, whatever the element is. Okay, now talking about the part from the right side. Okay, so how am I going to initialize this? So suppose say I will say int of r is equal to l. Okay, so now r and l, they are both pointing to that first element in my array. Okay, so don't get confused just because I said it's the right edge. Okay, we'll have both of them there. Okay, now what will be your loop condition? Your loop condition will be true forever until it is manually broken. How will you break it manually? We'll see. Okay, manually you only break it, like the swaps and all, they matter. Okay, that is when you manually break it. So we'll see. Now first thing is to determine how many swaps are actually allowed or actually that can be used. So let's say int, call this swaps allowed is equal to, so this is basically going to be min of k, or whatever the size of the inside array is, or whatever the size of the outside array is. Even if I have k, but my like suppose my k is 10, okay, and my inside array is just 1 or my outside array is just 1, I cannot do 10 swaps. Okay, because again, if you remember, it said that basically you should just be using one pair for once only. Okay, so that means that one element, whether inside or outside, is going to pair up with some other element, maybe making no or very negligible difference. Okay, so it should be min of k, comma, in of inside dot size, comma, it should be int of outside dot size. Okay, now the total starts as the subarray's sum before any swap happens, right? So how will you initialize that? Say long total is basically equal to whatever the inside sum is. Okay. Now iterator will always point to the smallest element inside. Remember this. We have to keep that. And the iterator will point to the biggest element on the outside. Then only we know the swapping technique. Okay. So let's take this to be auto, and let's say inside iterator, that is going to be inside dot begin. It is going to do it from the start to finish. And we'll also have an outside iterator, that is going to be outside. Now this should be r dot begin. Okay, I don't want it to begin from the left side because my subarray is starting from the left side, so my outside array should start from the right side, correct? So once this is done, now what you will do, you will try swapping the smallest element that is inside with the largest element that is outside, but you have to do that one at a time. So let's do this. Let's run a for loop. Say int of I is equal to 0 and I is less than swap allowed, and I plus plus. Let me give a space over here. Okay, just to make that look pretty. Okay, next is the current smallest value that is inside. Okay, so how will you invoke that? So we'll say int val is equal to, if I just do a star, because this iterator is pointing to that smallest value, right? So if you know the concept of pointers, then what am I doing in this step? That I'm telling my int val is stored in this star init place, where init is referring to the position. If I'm adding a star, then it is dereferencing that and getting me the value. All right, and similarly, what is my outside largest value? Then my largest value will always be similar, like dereference it with out it. Okay. Now, only you are supposed to proceed when there is a proper comparison that your out val is greater than your in val. Only in that case you are going to swap. Okay. And how will you swap? You basically have to add that total into, like, you need to just add that number to the total, correct? So how will you do that? Your total is equal to total plus what you can do is out val minus in val. Okay. You can do that. Increment your iterator, go to the next smallest element inside, and also increment your outside iterator that go to the next largest element outside. Okay. Come out of this if, write your else part. Now else part is to stop early if no further swapping will help. Okay, remember we did not have any loop condition, we have to put that here. So here what we'll do, we'll just break. Okay, come out of this for loop. And now what you can do is to update the best part, whichever chunk or subarray has the maximum value. Okay, so your best already had some value, so what you will do, you will say that either max of the existing best or total. Okay, and you can just increment your r. Okay, that means to grow your subarray by moving the right edge, because right and left, they were pointing to the same one, right? Initially, that is what we did. R was equal to L, right here. Now you need to increment your window. How will you increment your window? You definitely cannot move your L, but you have to move your R. Okay. Oh, I forgot the semicolon. Okay. Now, if we have already reached the end of the array, then you have to stop growing this subarray. So what you will do, you will just make a comparison that if R is greater than equal to N, then break. Okay. And then you're basically done with that entire sliding window thing. Now you can remove your A of R from outside, because it will basically now be inside, right? Because you have completed all the n elements, so it is inside. So what you can do is you can just do outside dot erase, outside dot find a of r. Okay, and also you can do inside, you need to just insert it. Okay, because you're already to the end, so you will just have to say insert a of r. Okay, and then you need to update your running sum, don't forget that. So let's do inside sum is equal to inside sum plus a of r. Okay, come out of this, and what are you going to print? You're going to just do C out, just return best, and we'll do end line. Oh, sorry, I just added that end line, and we'll return 0. Okay, so that is your entire code. I have added the comment lines. So let's take a look. I'm going to scroll from top to bottom once. So if you want, you can take a screenshot. If you want, you can pause the video, read the comment line. Everything is up to you. Okay, so it's the exact same code. I hope that you have understood the code. I've tried to be as like simple in explaining whatever I have written and why I have written it. Okay, so let's see. Okay, so again, the time complexity of this code is big O of n square log n, and you don't have to write this main because you will be given your own function name. Okay, so let's submit this and see. Let's take a look. So this is pending. Okay, so that is fully correct. That means it has passed all the test cases in C++. Okay, so now we'll be moving over and writing this code in Java. So let's code this in Java now. Okay, so we'll first get rid of the default. Okay, so for Java, the first thing we need to do is to import Java dot util dot star. Okay, now before I move ahead, definitely you guys can pause the video and try coding this on your own, and then you can jump back here. And second thing here is I am using CampusMonk's own editor, so I have to write the main function. It is not predefined, but in the test you will not have to write the main function. Keep this in mind. So what I'm going to do for this code is I'm going to put in my actual code also within the main function. Okay, but in your online test you will have to write just the function. Okay, and you will be given the function name that you have to use, so make sure you use that function name and not put it inside main. Okay, just an heads up, don't mess that up. Okay, so I'm going to put everything within my main class, but you will be asked to write it separately, so make sure they are separate. You're using the exact name as is given in the uh, the like whatever is asked in the test. Okay, so keep that in mind. Okay, all right, so I'm going to do a public static void main string arguments. All right, now you don't have to do all of this few steps that I'm going to do next. Okay, so for example, this one scanner SE, you don't have to do. Yeah, it's a good learning because this question can be asked even in TCS, right? In that case, you have to do all of that. But in for Infosys point of view, you definitely don't have to write it from scratch. Okay, you don't have to even write int n because this is just to take the input for your number of elements in the array. So I will do se dot next in, and similarly, I'm going to do int k that is equal to se dot next in. Okay. And then what else do we have? We have the array a that is equal to new int and the size will be of n. Now we need to loop to read each element of the array. So we'll do for int I is equal to 0, I is less than n and I plus plus. Okay. Now, once you have done this, we'll basically have to say that a of I is equal to, okay, why am I even putting it inside, right? Oops. Uh, Sorry. Yeah, I can just write it here because it's just one line of code. So let's do a of I is equal to se dot next int. Okay. Now, I am going to initialize a variable called as long best, which is going to store the best result, okay? The maximum rather, okay? So you can call that anything. We'll just use that towards the end of the code once. And this will be initialized to the minimum value, right? Why minimum? Because we are storing maximum and we need to keep track of the minimum. So what will it be initialized to? It will be initialized to min value of long. That should be your minus infinity, okay? So if we store minus infinity, then any number that comes in, like because we'll have negative values also, right? So even minus 5, minus 55, 495, whatever. So all of those negative values will definitely be greater than your minus infinity. Okay. So that is why we are storing the min value. Okay. Now your step is to, okay, so from here your code has started from this long best. Okay, this you has to go inside your function. Okay, all the top part, these will be already done for you because that's a part of the main function. And I repeat again, do not use main function as the function name. Okay, in Infosys you're writing just the function, stick to the function name they've asked you to write. Okay, now we loop over every element to figure out the possible subarrays. Okay, so we'll start from the left position. Why? Because we are taking the index 0 first, right? So let me take int L because I've used I over here for looping. I just want to keep it different, okay? Because we'll also have to expand our subarray length, right? So that is why we'll need L and R, okay? You can also take I and J, that is up to you, okay? Or J or K, whatever. So int of L is equal to 0. L must be less than the size of N and L plus plus. Okay. Now that you have this, we will need a map that will sort the like it's a multi set basically. Like you'll have two sets, right? One will be the inside subarray, one will be the outside subarray. Okay, right here. Where did that go? Here. This is the outside subarray and this one was the inside subarray. So you're having to have multi set. So let's take a tree. Oh, sorry. Tree map, and we'll say this is integer comma integer. Okay, and let's first declare the outside one. Say outside is equal to new tree map. Okay, now you need to loop through the whole array to build this outside map. So how will you do that? So say for int index, you're going to start at 0 always. Okay, and your index must be less than n, correct? And index plus plus. So what you're going to do? You need to add every element except the one where your L currently is. Okay. Except this L, everything else must go there. So you will say if index is not equal to L. Okay. Then outside dot merge. Merge will basically add it. What will you add? You will add A of index. Okay. Comma 1. Uh, like it will go from the first position and you'll say integer sum. Okay. So now you come out of this, and then we'll also have to create a similar map because it's a multi set. So we have created for outside. What about this inside one? So we have to create one for the inside. So we'll call tree map on integer, comma integer, and we say inside. Okay, that is also equal to a new tree map. Now, again, once you have this tree map, you need to insert the elements, correct? So how will you insert the elements? Now you will start where? From the L, right? From the first element, that is your first inside set, right? The first element. So what we'll do, oops, okay. So we'll say inside dot merge a of L, comma 1, comma integer sum. Okay. Now we need to keep track of the inside running sum also. So let's say long inside sum. Now, what will be the sum of the first inside sum? Like this one, it will just be one. So that will be initialized with that first value of a of L, correct? So that will be there. Now, the count of elements that is currently inside this sum, we'll have to keep track of that, as well as we have to keep track of the elements that is outside this array. So we'll say, suppose inside size is equal to 1, right? That will be what it will be initialized to. And similarly, what will be the outside size initialized to? It will be n minus 1, correct? Suppose n is 3, then if my inside is already having the first element, if I just consider these three lines, okay, the first element and my n is 3, that means my n inside has 1 already and my outside will have 3 minus 1, that is 2. Okay, so I hope you have understood this. Okay, next, what is your R? Now, your L and R is basically the start and the end point, correct, of your subarray. Now, initially, your L and R, where is it pointing to? It is pointing to that one number, correct? And then you're going to expand your window, you take the next one. So, initially, your R is equal to L, okay? And this loop will run endlessly until you manually break it down, okay? So, it's going to be true always. All right. So how will you do this? Now, the first thing is to determine how many swaps you can actually use. Say, suppose I say int swap allowed is basically equal to, it has to be the minimum of k. Now, you all will be saying that, oh, only k swaps allowed. No, it has to be a minimum of k, whatever is the size of your inside array and whatever is the size of your outside array. Why? Because if your k is bigger than the inside and the outside, then no matter what happens, you can never complete that many swap. Why? Suppose your k is 10, okay, and your inside array just has one element and your outside array has just two element. Okay, so even if your swap is 10, you cannot complete all 10 swaps because you're inside the array just having one element and in total you have three elements. Okay, so whichever is minimum, that many swaps will be allowed. Okay, so we'll do math dot min of k, comma math dot min of inside size, comma outside size. Okay, now we need to keep track of the total. But one thing, what is your total basically? Total, where does this start? It will start with your inside sum, right? This is the first value that will be initialized to the total, correct? So from there, you're going to figure out from all the total, which one is the max total. So let's do long total is equal to inside sum. Okay. And then we'll also need to take two iterators. First, the inside iterator. Second, the outside iterator. What will these two iterators do? The inside iterator will keep track of the smallest element that is inside the subarray, while the outer iterator will keep track of the element that is outside the largest element that is outside the subarray. So suppose I say iterator, okay, and then I'll say map dot entry. Okay, this might be new, but just look into this. This is the exact syntax. Okay, say I take inner iterator is equal to inside dot entry set dot iterator. Okay, and similarly, you will have the iterator, and you will say map dot entry dot integer, and we'll say out iter. and we call this on outside. And we'll do one thing, okay? We'll just make this a descending map. So we have the largest at the as the first element. Descending, CENDING, descending map dot entry set dot iterator. Okay, so let me just expand this window so that comes on the same line. Okay, now that you are done with that thing, the next one is basically you need to first have the like the inside, like you need to grab the first inside entry if that exists. Okay, and similarly you need to grab the first outside entry if that exists. Okay, so what will this basically do? This will sort it in ascending order, and here we have mentioned descending, so we'll have the outside thing sorted in descending order. Okay, so now we are sorted our inside element. If the first element is existing, if it is, and that is small, definitely, because that is how we have sorted it, will remove it and put in the larger element from the outside array. So let's just do that. So we'll do map dot entry. Map dot entry, it will be integer comma integer. And what do you want to call this? Let's call this in entry. Okay, is equal to in iter dot has next. So has next will fetch in the next element. If there exists and has next, then you will enter that into the like inside iter. Otherwise it's simply null. Okay, it's just return null. Similarly, we'll do map dot entry. Now we'll do integer comma integer. This is for the out entry. Okay, is equal to out iter, sorry, out iter dot has next. Okay, if there is an element in the out iterator array, then it's going to bring that in out iter dot next. Otherwise it will return null. Okay, now you need to track exactly how many copies of the current value we have used. Okay, because you need to make sure that when you are trying to swap in, you do it one at a time. So let's say in used is equal to 0, and out used is also equal to 0. Okay, now for int I is equal to 0, I must be less than swap allowed and I plus plus. So now this is basically you're trying to swap the smallest inside with the largest outside. Okay, so how will you find the value of that element? Because here all you have is these entry, right? These mapping, these iterators. So we'll do int val is basically equal to in entry dot get key. Okay, so this will basically get you the value, and then we'll have even the out val, because if we have swapped, we have to push in this value, in the inside value to the outside one and outside value to the inside one, right? So we'll do out entry dot get key. All right, and now once you have this, you will only proceed if the outside value is greater than the inside value, correct? So you will just do a check that if out val is greater than in val, only in that case what will happen to your total will be getting added with the out val, and you have to remove the in val. So it will be total is equal to total plus, we'll do out val minus in val, correct? And then you can do just increment your in used and also increment your out used. Okay, because you need to move on to the next value basically. Okay, so that is the thing. Now uh, so once you have incremented these things, now they have moved to the next inside entry and the next outside entry, correct? So how will you do that? So you need to check that if in used is basically equal to in entry dot get value. Oops, and in iter is, sorry, in iter dot has next exists. That means there is a next value. In that case, what you can do, you can say that in entry is equal to in iter dot next, and you can just say in used is equal to 0. Okay, Similarly, you have to do the same for out used because you have to move to the next outside element. So you will say if out used is equal to out entry dot get value and out iter dot has next exists, like the next item is there, it exists, then you will do basically out entry is equal to out entry dot next, and out used will be equal to 0. All right, let me expand this further so they all come on the same line now. Okay, so once we are done with that, so we'll come out of this if condition and we'll write our else condition. Now what will be the else condition? That is to stop early if further swaps are not helpful, right? So we'll just break out of the loop. So come out of all of this and you just need to update your best value. Now best value is basically best of all the totals that you have. So what you can do is math dot max of either best or total, whatever is bigger you print that. And definitely you need to increment your r. Why? Because initially, if you remember, your r was equal to l. Now you need to expand the subarray, you need to grow your window. So expanding or incrementing l will not help, you have to move your r. Okay, the right one. Okay, now suppose you have reached the end of the array, then what you need to do, you need to just stop increasing your r. So what will you do? You will say that if r is greater than equal to n, then break. Okay, now, suppose that v is the next value that is going to join the chunk. Why do I say next value? Suppose that is the last element. Okay, that r value where it is equal to your n, that also has to go inside, right? The complete array. So in that case, suppose we say int v is equal to a of r. Okay, in that case, what you have to do is to remove one v from the outside entry and just add it into your inside. Okay, so what you will do, because here it is getting over, so now your outside is also part of the inside because your r has become equal to n, that means the entire array is a subarray now. So you will do outside dot compute if compute if present, uh should be an opening bracket, I think. So we'll see if this gives an error. Okay, not sure. We'll have count key. Okay, and if count is equal to 1, in that case return, make that null and decrement your count by 1. Okay, and where will this v basically go? The last element, it will get merged in the inside list because now the entire array is a sub array that you're going to evaluate on. Okay, so we'll do that. Okay, now we need to update the running sum. So what will we do? Inside sum is basically equal to inside sum plus v. Okay, and then increase your inside size by 1 and decrease your outside size by 1. Okay, so come out of this entire thing and you can just print system.out.print, and what will you return? Let's do print ln and you will return best. Okay, so that is your entire code. I'm just going to add in the comment lines. So I will scroll once from top to bottom. So if you want, you can take a screenshot or pause the video to take a look at the comment lines that I have added. I've tried to be as descriptive in the comments as I could. Okay, rest it's up to you if you want to use this code or if you want to use your other code. You can definitely try changing the terminologies. You can definitely try using some other loop, whatever you want, or you can stick to this one. Definitely the time complexity of this is big O of n square log n. Don't forget about that. And if you are writing a solution, make sure it is either equal to my time complexity or it is at least less than that. Okay, do not write a code that is more than the time complexity that I have used. Okay, so yeah, and this time complexity will be accepted because a pretty complex code and it is not going to throw an error or timeout or anything like that. So the Java is pending. Let's see. So that is fully correct. That means all the test cases has passed in Java as well. All right. So now we'll go ahead and try solving this in Python. Okay, so now let's code this in Python. So in Python, I'm going to import few things. That will be system, and I'll import bisect. Okay, now you don't have to write the main function. Okay, I'll have to write it because the this is the IDE that we have on CampusMonk that I'm currently using. So you have to not write the main function, but I have to write the main function because we don't have an inbuilt main function. So, but in Infosys test, mind you, don't write the main function. Okay, so let's call this function say solve. Okay, we'll have three things. We'll have an n, we'll have an k, and we'll have an a, right? The size, the k limit, and the a array. So we'll say, suppose we call this final output to be the best maximum value. We store it as best, and we'll assign it the value of negative infinity. Why? Because if my array has -5, then that is going to be greater than negative infinity. Any number is greater than negative infinity, so we'll keep best to be assigned as negative infinity. All right. Now we have to loop over every possible value within that array to generate our subarray. Okay, so I'm going to take two variables here, the left variable and the right variable. Why left? Because it will have a starting point and it will have an ending point. Initially my left and right both will point to the first element, right? So let's say I will say for L in the range of n. Okay, now we have two arrays. One will be the outside array, one will be the inside array. Now outside array will hold every element that is not there inside my subarray. Correct. So let's say outside is equal to sorted. It will start from the start, okay, all the way till L plus. It should be A of L all the way. Sorry, A of L plus 1. We already have L there. All the way till the end. That is my outside. Okay. And what is my inside? My inside is just A of L. Okay, wherever this L is pointing, that is my inside. That is why if you look into this part, I don't have L. Okay, here my L will be excluded, and here it will start from L plus 1. So L is not included. That is my inside array. Okay, I hope you have understood this thing. All right, now I also need to keep track of the running sum of the inside arrays, right? So, sorry, inside like sub array. So I'll say inside sum is equal to, initially it will just be A of L, okay, to wherever that L is pointing. And also at the start, like I mentioned, your L and R will point to the same point, right? So your R pointer will also be there. Now once you're finished iterating on one element, then you will decide of expanding your window or expanding the size of your subarray. That is when we'll increment the R pointer. Okay, but how long will your loop run? Your loop will run infinitely until broken manually. Okay, so we'll see how we break manually. We'll have those steps. Okay. Next, we need to figure out how many swaps we can actually use. Okay. So we'll do swaps allowed. Now, why did I say that actually use? Because suppose if I have k is equal to 10, okay, and inside my array, I just have my inside array or my sub array has just one element, and my outside array that has just two element. So in that case, at max, I can just do two swaps. Either I'll swap inside with outside's element 1, or I will swap inside with outside's element 2. Not even two swap, just one swap. Correct. So then what will happen to remaining 9 swaps? Nothing. We'll not use it. So how many swaps are technically allowed? It should be min of k, or whatever, like it should be the min of k or whatever is smaller. Either it is the inside array or the outside array, whichever one is small, either k inside or outside. All right. And then what will happen to the total? Now, total is the one that starts calculating your current sum after any number of swap. So that is initially equal to inside sum. Okay. Now you will only swap the smallest in of the subarray with the largest element that is outside the subarray. Correct. So let's do for I in the range of swaps allowed. Definitely. Okay. So we'll have one variable called as outside val, which will keep the target, right? Like this is basically to get that element which is the largest and outside your given subarray. So outside val is equal to, we call the outside array. And we say, so from where should it start? It should start from I plus 1. Okay. So it's going to do it in the descending order basically. And in val is basically equal to your inside of I. Now this is going to sort it in ascending order. So your first character in the outside array is always larger and the one in the inside array is always smaller. Now once you have this, you're going to do one comparison. You will only swap when your outside val is greater than your inside val. Okay, otherwise do not swap. So in that case, what happens to your total? So your total is basically equal to total plus your outside val minus the inside val. Correct? Because you're adding the outside one and you're removing whatever the smallest element was inside in it. Okay? So you come out of this if condition, write your else. This is where you have to stop early or you're breaking out of the loop only when there is no further swap that you can do. So simply say break. Okay? Come out of this for, and what you're going to do is you're going to do another comparison. You're only going to update your best, if you remember this best, only and only if that if the total over here is greater than the best that you had declared above. So you will do comparison if total is greater than best. In that case, best is equal to total. Otherwise, you don't have to do anything. Okay. Now come out of this. You need to move your R pointer. Why? Because now you need to grow or you need to expand your subarray size. Initially, they both were pointing to just one location. Okay. Like right here, it is just pointing to one. Now you need to expand. So you need to move it ahead. So you definitely can't move the L pointer. You have to move the R pointer. Correct. The left will stay in the left only. So you have to increase your R by 1. Now suppose we have reached the end of the array. Okay, so we'll no further need to increase the r. So we'll say if r is greater than equal to n, in that case break. Okay, in that case break. Now v is the next value, like wherever it is ending, the moment your r is equal to n, right? That means it is pointing to the last element. So you still have that last element in the outside loop. What will you do? So your v is equal to say a of r. Okay, in that case we'll use here bisect. Now bisect will do what? It will basically remove it from the outside array and merge it into the inside array. So how will we do that? We'll say index is equal to bisect dot bisect left. We'll call the outside array, we need the v value, and we'll say outside dot pop. And what you'll pop? You'll pop the idx or the index. Okay, then we call the use the bisect and we'll say in sort, and we'll pass the inside along with v. So now your v is again in the inside subarray. Now so this is the complete subarray, like the complete array that is there. Okay, now once this is done, you need to update the running sum. So again, inside sum is equal to inside sum plus v. Okay, inside sum plus v. Okay, so you can just come out of this entire function and return best. Okay, because that is your answer. And finally, you don't need to write this. I'm going to write this because I don't have a choice. So I'm going to write it here. So first, but you can definitely watch this because if it's asked in TCS, it will come handy. So I'm going to do stdin dot read dot strip. We'll take n int and we'll say data at 0, and then we'll take k as int data at 1. Okay, because they're all provided in different lines, and a is basically going to be int x for x in data starting from position 2 all the way till 2 plus n. Okay, and finally we'll call print, we'll call solve, and we'll pass n comma k comma a. Okay, and come out of this and we'll call the main function. Okay, so now I'm going to just add in the comment line. So I'm going to scroll up and show you. I'll scroll down till the end so you see the comment lines and everything. Now if you want, you can pause the video or take a screenshot, whatever suits you, so you can read the comment lines. Okay, so I've tried to be as vivid as I could be while writing the comments or while explaining. Okay, so you're going to slowly scroll down. Mind you, the time complexity of this code is big O of n square log n. If you want to write a code of your own, definitely you can. But make sure the complexity is at least big O of n square log n or less than that. Do not write a higher complexity code. And if the question arises, is this optimized as n square log n? Yes, it is. Okay, it is optimized. And you can solve this. All right, so let's go ahead and submit this question and let's see. So the Python one is pending, and there you go. That is fully correct. All right. Now, before moving on to the next question, I highly recommend you guys to look into the description box for the like the course link and everything. We do have online classes, live sessions going on every week. Give those courses a try, and yeah, just let us know how you feel about the class, and we'll move on to the next question. All right. Okay. So now let's start with question number two. So let's read the question again as usual, and we'll be solving again in C++, Java, and Python. Okay. So first, let's read it, what it's trying to say. Now, this is one step up, and this is more complex. Okay. Question compared to the one that we saw prior to this. Okay. So this is also another PYQ question from Infosys, but we are going to see it slowly and steadily what it says, and we'll solve accordingly. Okay. So the first thing it says that you are given an undirected graph. Okay, so now this question is from graph. Okay, so mind you, complexity can be different, it can be higher. Do not think that, oh, if the complexity is n square, then that is brute force. Okay, just an heads up. So this is an undirected graph with n nodes and m edges. Okay. Usually we take u and v, but here it is m and n, or sometimes we also take as v and e. Okay. So v as the nodes, like the vertex v, and e as the edges. That means the lines or the direction how the graph is connected. Okay. Each node has u. Each node u has a layer L of u where the integer from 1 to k. So L of u is basically an integer from 1 to k and a value v of u. Okay, so there's a layer L of u along with the value v of u. You must choose a simple path, no repeated nodes. That means you cannot repeat one node. So that means all path must be unique. Okay, such that the layer constraint along the chosen path, the sequence of layer must be non-decreasing. Penalty for layer jumps whenever the path moves from a node with layer x to layer y. Okay, so I think these are all different points. Okay, the first one is the layer constraint along the chosen path. The sequence of layer must be non-decreasing. Then the next one is the penalty for layer jumps whenever the path moves from node with layer x to layer y. That means if you are jumping from layer 1 to layer 3, probably there is a penalty. We'll see what is the penalty with layer x to layer y. Okay. Okay, so overall the question is saying basically it is an undirected graph where the nodes are connected to each other. You have to choose a simple path. Okay. You have to choose a simple path, and that each node has a layer L of u and a value v of u. Correct. So we'll just put these things down. So we have nodes. Correct. Each node is connected with edges, and each node has two things. One is the layer, the other one is the value. So your layer is denoted as L of u and value is denoted as V of u. Okay. And then it is saying that then you must choose a simple path and no repeated nodes. That means the path is unique such that the layer constraint along the chosen path. So this is what are the layer constraint along the chosen path? The first thing is the sequence of the layer must be in non-decreasing order. Okay. So you need to basically choose a path such that point one, the layers are arranged in non-decreasing, right? It says non-decreasing, arranged in non-decreasing. That means in ascending order, correct? Next, point two. There is a penalty for layer jumps whenever the path moves from node layer x to. So there is penalty for uh, what layer jumps. Okay. Then it says that you pay the cost. So the penalty is basically using this formula. So that is 2 times of penalty is 2 times of x minus y. Okay, so basically the jumps. And third, it is finally telling you to find the maximum value of. So this is the thing that you have to find. Sum of the path minus the sum of the penalties. Okay, so you're basically finding the max sum again. Okay, of the given formula. All right, so this is the overall question. Now let's understand the input format. Okay, the input is huge. Okay. So it's in first line contains the integer n denoting the number of rows. Okay. Then the next line is m, which is probably the edges, correct? The next line contains an integer k denoting the max layer. Okay. So we have a limit on the number of layers. But I feel like this is very useless information. They've just given it because nowhere are they using it. Just that it is a range that is given. That's it. Okay. So I don't think we are going to use this value, but we still have it. So we'll stick to that. Each line I of n subsequent lines. Okay. Contains two spaced integers. Okay, so there are two integers separated by a space. Then I think this one is of this part only. It's not another point. Integer each describing the row, and then it says each line I of m subsequent. Okay. Again, this one is of this one's part. Fair enough. And there are each rows I that contains two spaces separated by. Okay, so basically that is u and v. All right. So these are couple of information that is given to you, and this is how I have broken down the question. Now, if you guys want, you can pause the video and try this question on your own. Otherwise, let's jump into the question. Okay, so few things that we need to keep in mind. It says, okay, so first is n. So first, let's understand this. N is basically saying your. Actually, let's look into the input. Okay, so input is pretty weird. Okay. Okay, now let's consider this way to make it easy. Okay, so suppose nodes are your, we'll consider this like this. Okay, so let's consider nodes are nothing but rooms. Okay, so let's make this a game. So you basically have to consider this, that n basically denotes the number of rooms or number of nodes that are there in that particular graph. Okay, m basically, let's take this m as your, like, it's already known as the edges, correct? That is the edges, but let's consider this to be the hallway. Okay, that is connecting the rooms, correct? So this will basically be number of hallways. Okay, and then we have k, which is basically the highest, or rather to say it is the max possible rooms. Okay, so it's like possible room per layer, I would say. Okay, because it is L of u and that has a range of 1 to k. And to be honest, I don't think we are going to use this variable. It is just given. You don't see that in the math in the question that is given. Okay. Then it says that n lines after these three values that denotes the like one room per line, telling you that this is the room number and this is the floor and how much value, or let's say that room has a treasure. Okay. So suppose this room has treasure. So it basically, the n lines tells you the room number. Okay, and all along with how much value, okay, or the treasure that you want to call. Okay, suppose every room has a treasure. Okay, we are just changing the entire vibe of the question into some game. And then so this is basically next n lines. Okay, and then we have next m lines, that is basically telling us that which two rooms, we can put it down as which two rooms are connects each other. Okay, so this is the overall gist. So there are rooms, there are hallways, and then you have a limit on how many layers are there. Okay, so we can ignore that. And then you have the value of the room number along with the treasure it has. Okay, room number probably with the floor or the layer or the, yeah, layer basically, because L of u along with the V of u, correct? So it basically tells you the layer also. And again, then you have the M line, that is the hallways, basically the edges, that is telling you which two rooms are connected. Correct. So this is the thing. Alright, so now let's go back to the question. It is saying find the maximum value, that is sum of V of u, that means the treasure, the value that we have over the path, minus the sum of penalties. Now, if you jump the layer, you definitely have to pay the penalty. Correct. So it is basically like you start walking. Suppose, let's understand this. Okay, so suppose this is room A. Okay, you start walking from any room you like. Okay, it doesn't matter. Let's start working from here. And you only walk to a room on that same layer or that same floor. Okay, or to a room on the higher floor. Okay, so suppose this is the first floor and then you move here. This is the second floor. Either you go to a higher floor or you go to a lower floor. Mind you, this is an undirected graph, so you can walk both ways. That is why it is a hallway. Okay, but you never go down. That means from second floor, you don't go to this basement. Suppose this is the basement. Neither do you go from first floor to the basement. Okay, and every you walk a floor higher, you get a penalty. Okay, so penalty is basically equal to how many floors you jumped. Okay, so the farther you jump, the more is the penalty. Suppose I go from basement, that is the 0th floor, to first floor, my penalty is 1. Okay, suppose I jump from 0th floor to second floor, my penalty is 2. Okay, and at the end, you want to end your work by having collected the maximum number of treasure. Okay, after subtracting all these penalties. That is the overall question. Got it? Like I have put it down in some story format. So I hope you have understood this. I'm sorry, the question is pretty clumsy. I did not make this question. This was done by Infosys. So I know it's a little complicated to understand it here, but it is as simple as this much. So there are multiple floors or layers. You can definitely go higher, but never go down. Okay. And whenever you're jumping from one floor to another floor, whatever is the floor number, that much penalty you pay. So at the end, you basically have to figure out the most treasure, because every room is having some treasure, that is some value, right? Some value is given, v of u. So you're collecting those treasures, but at the end you have to give the maximum sum of the treasure minus these penalties that you would have paid for jumping the floor. Okay, that is it. Now if you want to try it, you can try it on your own. Otherwise, let's take a look on few dry run. Okay, let's understand the question. So if I talk about this first example, okay, let's see. So it says that it is 2, then 1, then 10, then we have 1, then we have 10, then we have 3, then we have 100, then we have 0, then we have 1. Okay. So if you remember, this was n, this was m, this was k, correct? Then these are basically the n number of things. So this is n of I, and this is again n of I, and this is m of I. Okay, because we have 2n, so 2n, and 1m, so 1m. Okay, now let's break this down. What was this? This is basically number of nodes or rooms, correct? So how many rooms do we have? We have 2 rooms. Okay, so what is this? This is the number of edges or hallways. So how many edge do we have? One hallway or one edge. Okay, or 2 nodes or one edge. And this is k, so we don't have to consider it because it's nowhere used in the math, so you can just ignore this. This is just the limit, which is okay, fine. Okay, so just ignore it. Now it said that what is this 1 and 10? It is the layer along with the value. So this is the layer or the floor, this is the treasure, this is the layer, this is the treasure. Okay, so suppose this is room number, say 0. Okay, so it is situated in floor. Which floor? This is the floor or the layer, correct? Floor or layer. Which, what is that? That is 1. And what is the value or treasure? That is equal to 10. Correct. Similarly here, suppose this is room number 1. Okay. So what is the floor? Floor is the first value, or what is the layer? Layer is basically 3. That means to jump, I will have to pay how much penalty? 3 minus 2, that is, sorry, 3 minus 1, that is 2. Correct. And value or treasure over here is 100. Okay, and this is m, that is basically hallway. There's a hallway, right? There will be staircase in order to go from one floor to another, that is called an hallway. Or there is an edge which is connecting room 0 to room 1. Okay, all right, so this is the overall thing. Now, so let's understand, like now we have broken down this entire thing. So your room 0, okay, room 0 is where? It is on the First floor. Okay, it is on the first floor. And how much value does it have? It has 10. What about your room 1? It is on the third floor or the third layer and has value 100. Okay. Now suppose you start at room 0. Okay. You start at room 0. Now you will do what? Now you have this value, you have this treasure. So will you leave it or you take it? You will take it. Correct. Why will you leave it? You have initially you have 0 before walking into this room. Now if you get 10, you're going to collect it, right? Why will you leave it? So you collected 10. Okay. Now what will you do? You will start to walk from this room to this room through the hallway. Correct. So you were in first floor, you jump to third floor. So what is the fine that is paid? So if we just go back to this question, let me just check where is the penalty. Oh, okay, it is 2. Is it 2 times or 2 square? You know what, I think that is 2 square. Okay, because the math will not fit. uh no worries, I will try to update this question properly in the comment section. So just type in PDF if you need the complete correct question. I'm not sure what has been updated over here from the test paper or something. But yeah, if you want the complete question, proper question, I'll decode it. Put down in the comment that you want the PDF and let me know. I will share both the questions. Okay. And if possible, I'll share the answers as well. Okay. So just comment below. All right. So what I feel is it is basically your y minus x because that 2 is written afterward, not before. Like had it been 2 times, it would be at the start. So I'm assuming that is the square. So y is this, x is this. Okay. So 3 minus 1 to the power 2 is equal to 2 to the power 2, that is equal to 4. Correct. So this is your penalty that you will pay. Correct. So since this is the penalty, remember this value, we'll subtract it at the end. Now you have already collected this 10, you paid the penalty. So let's subtract it here only, no problem. So how much is this? This is minus 4, which is equal to 6. And then you reach here and gather this amount. So total is 106. Okay. So if we check the answer over here, okay, so the output is 106. Correct. So that means that is square. Okay. All right. So that is your answer. Okay, similarly, let's just look up for another thing. Say the value is like this. Uh, 220, 330, 0, 1, 1, 2. Okay. So here, this was the only hallway that was connecting. Okay. So there was no other hallway. So you never had another choice. But it would be interesting over here to see because you have two M of I, two hallways are there. We'll see how we go about that. So this is N, this is M, this is K, which is not of any use. This is N of I, this is N of I, and this is also N of I. Correct? Now, so we have 3 rooms. Then we have 2 hallways. Okay. And here we have like this is floor 1. Okay. So this is floor. You know what? Let's write the room number also so it is easy for us. So this is say room 0. It is on floor or layer 1 and value or treasure is basically equal to 10. Okay. So say this is room 1. This is on floor 2. The value or treasure is equal to 20. And similarly here it's room 2 and floor is 3 and value or treasure is equal to 30. Okay. Now there are two connection that is given. That is room 0 connects to room 1 and room 1 connects to room 2. That means all the rooms are connected. Okay. Now what will you do? You will start walking from room 0. Correct. In room 0, what is your treasure that you have? Exactly 10. So what will you do? You will collect that 10. Correct. And then you will move to, because the hallway connects room 1. So you have to go to room 1. Okay. So room 1 is in which floor? This. And room 0 was in this floor. Correct. So x minus y to the power 2. So y is 2 minus 1 to the power 2, which is equal to 1 square, that is 1. Okay. So either you can take it out right now or you can keep this penalty in mind because we'll have another penalty as well. So we'll have to add up all the penalties, correct? So 10. Now you are in floor 2, correct? Sorry, here. For room 1, floor 2, correct. So how many treasure do you have? 20. So you add that up. Okay. Now you'll take the next hallway, that is room 1 to room 2. Now in room 2, which floor are you in? Third floor. So again, what will be your penalty? So here it is 3 minus, from where did you come? You came from room 1, so that is in floor 2. 3 minus 2 to the power 2, that is equal to 1 square, that is 1 again. So these are your penalties, 1 and 1. So we'll keep that in mind. Now you are here, so this is your treasure, add that. Okay. So what is the value? It is 60. Now you have to subtract these penalties. So total penalty is 2. So minus 2. So 58. So let's check if the output is 58. Yes, it is 58. Okay. So that is how you're going to solve it. Okay. So you can give yourself a try and you can try for this. Say suppose n is equal to 3, m is equal to 2, k is equal to 3. Then you'll have say n of I as 1 first floor, treasure is minus 5. Then say you have second floor, treasure is 100, n is equal to I, you have say 3, treasure is minus 10. Then you have m of I 0 and hallway connects to 1 and another edge that is 1 connects to 2. Okay. So this is your thing. Give this a try. Pause the video. Try to solve it on your own. Your answer should come out to be 83. Just check this on your own. And I hope you have understood the whole summary. I've tried to bring it down to as simple form as I can. Okay. Because the question is pretty clumsy and I agree with you. Okay. Now, so one thing I would say is that after doing this dry run, let's understand what should be the steps basically. Okay. So first is definitely to take in the input. You need to read in all this. Okay. Read everything. All right. And then the next thing will be to basically line up the rooms. So let's say line up the rooms and lowest layer or floor comes first. Okay. Next, for each room, you need to ask two questions. First, if I walk in from one of my connected lower room, what is my best possible way? The second, would I be better off just by starting up my line from somewhere else? To matlab, first is like, should I start from zero? The second question is, or should I start up randomly? Okay, and ignore everything from before. Okay, so or start somewhere else, ignoring previous before treasures. Okay, so why did I say that? There can be situation where suppose this room itself had a treasure of 1,000. Okay, so this is too big compared to the penalties and everything. So I would rather go here directly and ignore all of these treasures. Okay, so I can make a call. So these are the two things that I need to take care of. All right. The fourth thing is to add the room's treasure on arrival. Okay, need to add treasure basically. Okay, and the fifth one is that after every room is completed, you just need to return the biggest treasure value. Okay, so these are the five things that you need to keep in mind while you are coding. Okay, that is it. So if you want, you can again pause the video, write your own code, whatever language you want. Okay, so here the code that we'll be writing will have the time complexity of big O of n log n plus m. Okay, actually I gave the wrong bracket. Okay, and space complexity definitely for this one, like even if I take a wild guess, it would be big O of n plus m because we are storing all the nodes and the edges, and this is a graph question. Okay, so most of the graph question has a space complexity of this. Time complexity is also most of the time n plus n, but for this code specifically, because we have other things to do as well, it will be n log n plus m. Okay, so now let's start coding this. We'll start with C++, and Let's see how we do that. Okay. So let me expand this window and let me get rid of whatever is written over here. So when you're writing the code for Infosys interview especially, you don't have to write the main function, okay? The main function will already be written for you. You just have to write the function, okay? But here the IDE that I'm using is solely related to CampusMonk, so I don't have the privilege of having an ready-made main function. So that is why I'm going to write it inside the main function, but you don't have to write the main function. Keep this in mind, okay? So we'll do bits slash std dot header and using namespace std. Okay, so I will just put everything inside my main function like I have said, but you will have a separate function name. Okay, you don't even have to declare all of this. So int n comma m comma k. I'm going to do c in and I will take in. Okay, you don't have to do this step as well because this is just for the input and you don't have to take the input. Your function is just to write the code, but this is a good learning thing because if this question comes in TCS or some exam where you have to write the code from scratch, you will get the hack of it. Okay, so this is for the layer. Then we need to take one more for the value. So let's make this long because value, we don't know how big the treasure will be. So value at n. Okay, now we need to loop through it. Again, you don't have to do this because this is again part of the input. Okay, so for int is equal to 0, I must be less than n and I plus plus. So we'll do c in, we'll take layer at I and we'll take value at I. Okay, now once this is done, after this you have to take write your code. Okay, so from here you have to focus. So we need to create an adjacency list to store these connection, like who's adjacent to what, right? So again, I don't think you have to do this. No, you don't have to because this is basically taking the input for m. Okay, so we'll say vector of vector int and let's call this adjacent and we'll parse n so we have the connections. Now we'll have to loop through all these edges, so we'll say int of I is equal to 0, I must be less than m and I plus plus. Okay, and we'll need to declare the edge endpoints, that is u and v. So let's say int u comma v and we'll do c in, we'll take u and v. Okay, now we need to add v as the neighbor of u and u as the neighbor of v. So how do we do that? A adjacent, like whatever is the name of your vector, dot push back v. Okay, same thing we'll repeat with the opposite, that is vu instead of uv now. So we'll say v dot push back u. Okay, so come out of this for. Now that you have everything in place, now we need to create an array that will hold, basically it's going to hold all the nodes in a sorted manner. Okay, now we need to sort it because if you remember, that was the first step, right? That the floor must be lowest floor must come first. Okay, so what will we do? We'll say vector, let's say int, we'll call this order and we'll order n, correct? Now we need to fill the initial all the indices with the values from 0 to n minus 1. So how will you do that? You will loop through it again. So I is equal to 0 and I must be less than your n and I plus plus. Now within this loop, we need to sort the node now by layer. That too, it says in non-decreasing. That means in ascending order. So I'll use the sort function and we'll do order dot begin comma order dot end. Okay, and we'll parse the sorry int of a comma int of b. Okay, and how you going to compare this? You're going to compare this based on the value. So we'll say that now if you think what does this int a, we'll figure this out right now. So it should be that layer of a must be less than the value of at the layer of b. Okay, this is exactly what we are trying to do. Got it? Okay, I think I came one step ahead. This bracket must be outside. Okay, so that is within that. Clear? Now, once you come out of this, you need to create. Now, this is a graph. Be sure that you need to create a DP. Okay. So, we need to create a DP array that will store the best score that is ending at each node. For every each node, we need to do that. So, we'll say vector long, long again. And let's call this DP. You can call best also. You can call anything, any name. Okay. Now we need to process the node in increasing order of the layers. Okay, like layer 1 or floor 1, floor 2, like that. So let's say for int, I'll take this as index is going to start from 0 and index must be less than n and index plus plus. Okay, now what you need to do is to get current node from the sorted order. So let's say int u is equal to order at index. Now you need to track the best score, the incoming score. Okay, but your best will start from 0. Like initially it does not have any value, right? Now best is what you're going to basically return, not return but store the value. Okay, so we'll save that. Like it is basically incoming score. Okay, but defaulted to 0. Like it will be initialized to 0. So we'll say best is equal to 0, and then we'll loop through the neighbors of the current node, right? Because this is a graph, so you have to go to the next one, like for the layers, all the edges. Say in p, and we'll do adjacent and u. Okay, and now you will only consider the neighbors that are strictly in the lower layer. Okay, so we'll say if the layer at p is less than the layer at u, in that case what you're going to do, you need to calculate the layer jump. Okay, so how will you do that? We'll say long long, say we'll call this as the difference is equal to layer of u minus layer of p. Okay, once you have calculated that, you need to calculate the score if extending from the path, like from p minus the penalty, correct? So you need to figure out that value. So you will say let's take this as candidates. Okay, I'm just taking random names. Okay, just make sure you give some apt names. So dp of p minus the difference that we calculated. So we'll just do it as difference times difference. Okay, we'll just do this. Now you need to update if this candidate is better or not. So just check if this candidate is greater than the actual, the best that you had. If that is the case, like I said, we have to update our best, obviously. So come out of this for loop, and finally what is your dp value? It is basically the first value, like the own value of that rooms, that floor, plus the best value, right? That is what we have been doing all together. Penalty was subtracted, but we added the remaining rooms value, right? So we're going to do that. So we'll say dp of u is basically equal to value of u plus best. Okay, so you come out of this, and now basically we need a variable to store the final maximum answer. So let's call this long long answer set to 0, and now we need to loop through all the dt values. So we'll say for int of I is equal to 0 and I must be less than n and I plus plus. So you need to basically track the maximum dp value. So what you will do, say if dp at I is greater than answer, in that case just update your answer to be equal to dp of I. Okay, so come out of all of this. What you can do is see out. What will you print? You will print answer and you will do end line. Okay, finally return 0. Okay, so that is it that you have. All right, so I am just going to add in the comment lines. Okay, and I will scroll once from top to bottom so you can see it, and then we'll go ahead and run. So just mind you, if you want, you can pause the video, read the comment, or take a screenshot, whatever fits you. You can always try optimizing the code, but this is one of the best optimized code that I have given you. For Infosys, you don't have to do the input part, but you definitely have to do the other part, that is the functional part. Okay, and also the time complexity of this code is big O of n log n plus m. Okay, and space complexity is just m plus n or n plus n, whatever you want. Okay, so let's go ahead and submit this. So this is pending. That is fully correct. So that means it has completed all the test cases or passed all the test cases successfully. Okay, now we'll go ahead and solve this in Java. So let's solve this in Java. We'll get rid of whatever is written over there. So first thing, we'll do import java.util.star. Okay, again, just to mind you, you are not going to write the main function, but since we are using Campus Monk's own IDE, I have to write the main function because we don't have the predefined main function. In Infosys Online Test, you don't have to write the main function, so do not copy this. You can copy the function, the main function, the logic, but the main function name, just change it to whatever has been asked in the exams question paper. Okay, whatever they would have mentioned it there. Okay, so just do that. So I'm going to put everything inside my main class. So you can make separate class, separate function. Okay, you have to make separate function. Keep this in mind. Okay, so we'll do public static void main. Okay, you don't have to do this part in Infosys, but this part will come handy when you're answering TCS or any other such exam where you have to write code from scratch. Okay, now we have to take three inputs. So one is n, that is equal to se dot next in, and then we have to take input for int k. Sorry, it was int m, I guess. Yeah, int m, that is equal to se dot next int, and then we have int k, that is equal to again se dot next int. Okay, we need two arrays that will store the layer, that is the floor, and the value or the treasure. Correct. So we'll say int layer is equal to new int, the size will be n, and similarly we'll have int value, which is equal to new in size will be n. Okay, all of this you don't have to do it in your Infosys exam. Okay, one thing, this is value, so it can be as big as possible, so we'll just change that to long. Okay, now we need to loop through each of this to extract the value for the layer and for the value array. So let's do that. So we'll do for int of I is equal to 0 and I must be less than n, I plus plus. So we'll say layer of I is equal to se dot next int, and similarly value at I is equal to se dot next int. Okay, so we come out of this for loop. Now we'll basically again have to make an adjacency list for the edges. Okay, so we need to make those node connection. So we'll make it as a list of list and call this of type integer. Let's call this adj as adjacency short form, which is equal to new array list. Okay, so again, you don't have to take this because this is a part of the input, but I'm just showing it, and because as it is, I have to write that piece of code because otherwise the code won't run. But for Infosys point of view, you don't have to write this input part. Okay, we'll do adj adjacency dot add. We'll add new array list. Okay, so come out of this for loop. Now you need to loop through all the edges. So we'll say for int I is equal to 0, I is less than m, and I plus plus. Okay, so we'll read the first endpoint of the edge. So that we'll read it in u, and we'll say se dot next int. And then we have to read the second endpoint, that is the v. So we'll say int v is equal to se dot next int. Okay, and then we need to set that u is the neighbor of v and v is the neighbor of u. So how will you do that? You will do get u dot add v. Now this is one sided, that v is the neighbor of u. Now you need to set u also as the neighbor of v. So you will do adjacent dot get v dot add u, because it is a hallway and it can go both ways. Okay, remember that. So that is why we need to add both. This much part was just your input, which you don't have to do. Okay, this will all be done and sorted. You need to start coding from here. Okay, the first thing that we'll do is to take an array and call that order. Why? Because we need to sort it. Okay, the array nodes has to be sorted according to the layer, if you remember. Okay, so we will first have to sort it. So we'll say new integer. What will be the size? It will be n. Okay, so we need to loop to fill the order with the respective indices. Correct. So how will we do that? We'll do that of as int of I is equal to 0. I must be less than n. I plus plus, and order of I is equal to I. Okay, so you come out of this, and then what you will do, you need to sort the node indices by layer, but in ascending order, because the question says non-descending, that means ascending. So you will do arrays dot sort order comma b comma a comma b. Now what does this mean? It means that it should be layer a minus layer b. Okay. Now we'll create another array to store the best score ending at each node. Like for one particular room, whatever is the best score, we have to store that. So let's create another array. We'll call that dp, say, and we say new long, and size will again be n. Okay. Now we need to process the node in increasing order of the layers, right? By increasing floor. It can't be 2, then 1, then 3. No. It has to be 1, 2, 3. So we'll do for, say, index is equal to 0. Index must be less than n, and I plus plus. You will say int u is equal to. So now this is going to get the current node from the sorted order. So you will do order at index. Okay. And then you need to keep track of the incoming score. But how will you keep track? Like, first let's initialize that. Say call that long best is initialized to 0. Okay. And then we'll have to loop through the neighbors of the current node. So we'll take another variable, say in p, and we'll say adjacent dot get. We need the neighbors of the current node. So current node is u. So we'll do that, and you will only consider the neighbor that is strictly lower. Okay. So that means I'm going to subtract a higher value from the lower value. So how will I do that? First, though, I need to check this condition, that if layer P is less than layer U, only in that case I'm going to find the difference for the penalty. So that will be difference will be layer U minus layer P. Okay. Now once you have this, you need to calculate the score for the path that is extending from that node P minus the penalty. Okay, so let's call this as candidate. I'm just giving random names. Okay, you can call it appropriately. Minus, how is that calculated? Square. So we'll just do diff times diff. Okay, so that is basically square. Now you just need to check if your candidate value is greater than the existing best, then update the best. So we'll check if candidate is greater than best. In that case, best is equal to candidate. Okay. So come out of these for loops, and what you're going to do, you need to add this dp value. So you will say dp of u is equal to basically whatever the final treasure will be plus the existing best value. Okay, so all the previous plus the current treasure. Okay, so come out of this. Now what you need to do is you need to store your final answer. So let's call this long answer is equal to 0, and now you need to loop through all these values of the dp that you have. So let's do this. Like we'll say int I is equal to 0 and I must be less than n, I plus plus. So we'll just check that if anywhere your dp of I is greater than answer, the existing answer, then your answer is equal to dp of I. Correct? Now just come out of this. You can do system dot out dot println. Let's print answer. Okay, and if you want, you can just do se dot close. Okay, reason for se dot close, it's a dynamic memory. You need to deallocate the memory basically. Okay, so I am going to add in the comment lines. I will scroll once from top to bottom. So if you want, you can take a screenshot or you can pause the video to read in the comment lines. I've tried to be as vivid as I could be while writing the comment lines. Rest, if you have any doubt or any question, put it down in the comment section. I will try to reach out to every single possible questions. Okay. Mind you, you can definitely write your own code. You don't have to stick to this code, but definitely try to write a better code with a better complexity. By better code, that I mean is writing it with a better complexity which is less than log of, sorry, big O of n log n plus m, and a better space of better than big O of n plus m. Okay, so try that. Otherwise, you can stick to this one. Let's go ahead and submit this and see. So this is pending. That is fully correct as well. So this means that it cleared all the test cases even in Java. Okay. So now we'll be moving on and writing this in Python. Okay. Now let's try this in Python. So the first thing in Python we can do is to import system. Then again, mind you, I'm going to use everything within the main function, but in your Infosys test, you're not allowed to write the main function. Main function will be written for you. You just have to write the function. So stick to the function name that they have provided. Do not change that to main. Here I'm using CampusMonk's own IDE, so there is no predefined main function. So I have to write it over here. Okay. So this can be a good practice for you in case you are writing a test like TCS where you have to write the code from scratch. You can follow this. Okay. So first let's take in the input. So I will do stdin dot read dot strip idx is equal to 0. You don't have to do all of this in Infosys exam. I'm repeating it again. So don't write this. Okay. This will be already done for you. So then we'll do data idx. So IDX is basically a pointer that will track your current position in the tokens. Tokens means whatever the input will be there. Okay. So we're taking the input for n, and then we'll just increment our counter so we know how many values we have entered. Can't be less, can't be more. It has to be exactly correct. So m is equal to again int of data. We'll pass in IDX and we'll again increment that by 1. And we'll do the same thing for k. Okay. All right. Now after this, we need two lists, one for the layer, one for the value or treasure. So layer is basically the floor. So let's do this. So all will be initialized to 0, all the values. And how what will be the size of this? It will be same as n. And then we'll have value, which will also be initialized to 0, all the values within that list, and that size will also be n. Okay. Now, you don't have to write all of this. Okay, this is part of the input. So again, we have to take further input also. We need the value of layers at I and layers at V, and also we need the values of the edges. Okay, so there are couple of things that we need to consider. So now let's loop in. So we go through all the nodes. So for I in the range of n. Okay, first we'll append the value of layer. Correct, because that is how our input was. First we had the layer, then we had the treasure. So we'll say layer is equal to int of data idx and just increment your index, like that's just a counter. Okay, and then we'll have value at I that is equal to int of data idx, just increment that. Okay, now all of this are part of your input, so just forget it, like if you're just preparing for like Infosys. Okay, next we need to create an adjacency list to store all the edge connection or the node connections. So how will you do that? We'll say for like it's an empty list in the range of n. Okay, everything is in the range of n. It cannot exceed your number of nodes. Okay, now you need to loop through all the edges, and also make sure you make the connection. Okay, so again this is also part of your input. Okay, this will be already done for you. So we'll say u is equal to in data idx, and this is the starting, like this is one of the endpoint of the edge. Then we'll also have v as another endpoint of the edge. Okay, so v is equal to int data. Now this is the second endpoint of the edge, like edge will have two ends, right? So u is the first end, v is the second end. It's same idx, and just increment that. Okay, now once you have done this, you need to make sure you connect the edge u, the end of u with end of v, and again end of v with end of u. Why? Because that is undirected graph, so that means it can move both ways. Okay, had it been directed, we would have only connected one. So how will you connect that? We'll take the adjacent of u dot append. What will you append? V. And similarly you will do adjacent dot v, you will append u. Okay, now once you have done this, now you come out of this for loop, and this is where your coding part begins. This is all your part of the input and all of that. Okay, We will take a variable order and we'll basically sort the node of the indexes in ascending order of the layer. Okay, so we'll say sorted in the range of n. Okay, I'm going to use a lambda function. So we'll say key is equal to lambda when x is basically where in is your layer x. Okay, so it's going to sort it in ascending order. Then we need to create a list that is going to store the best score after every node, after every room that you have gone, you have fetched the treasure. So it is going to store that value, that treasure value. So I will say this as dp is equal to all, initially it will be all initialized to 0. What will be the size of the number of nodes? Okay, now you need to process these nodes how? In increasing layer order. Okay, so say for u in order, okay, we need to store the best score also. So we'll say best is equal to 0. And now we'll loop through the neighbors of the current node. What is our current node? That is u, because that is what we have taken here as the variable. Okay, so I will say that, say for p in adjacent of u, I'm only going to consider the neighbors that are strictly in the lower layer, right? Because I have to go higher. So what will I check? I will check that if layer of p is less than, sorry, if the lower layer of u is less than the layer of p, okay, only in that case I'm going to calculate a difference. I actually wrote it opposite, I was writing it correct. So if the layer, yeah, if the p, the adjacent one, is less than the one that you're currently iterating over, then your difference is equal to layer of u minus layer of p. Okay, so you're calculating the jump, the penalty. Okay, you haven't calculated the penalty. Penalty will come here. Okay, so this is basically the jump, that initial difference. Okay, now let's say I'll just call this variable candidate. You can call anything. So this is the final calculation. How will you calculate that? Dp of u, whatever is the value, minus the difference. It's basically square, so I will just do it twice. Okay, difference times difference. Okay, now what you're going to check? You're going to check that if your candidate is greater than best, just update your best to be your candidate. Okay, now you're just going to come out of the for loop. Okay, and you're just going to say that dp of u is going to be equal to the current treasure value, okay, plus the best. Okay, so here you are doing it on single level, here you are doing it on a higher level. Okay, understand that. Best. Now you come out of this, and what you will do, you need to store your final answer. So we'll set that to 0. Okay, this is the variable where you're storing the final answer. Okay, and you need to loop through all these dp values that you will have for every dp value that we have in the list. So then we'll do for I in your range of n, if your, sorry, if your dp at I is greater than the existing answer, then append your answer or just change your answer to be dp of I. Okay, come out of this for loop and just print answer. Okay, and come out and call the main function. Okay, that is it. I'm going to paste in all the comment lines. We'll scroll up and I will scroll down once so you can see all the comment lines. If you want, you can take a screenshot or pause the video to read through. I have tried to be as vivid as I could while writing the comment lines. Rest, if you have a better solution to this, definitely go for it. Just make sure that the time complexity is lesser or equal to the time complexity that I've given, that is big O of n times log of n plus n, and space is big O of n plus m. Otherwise, stick to this code. I know it's not an easy question. Completely understand a lot of things is happening over here, but these are the level of question that Infosys has asked and will continue asking. So you better be prepared for it. Let's go ahead and submit this code. Let's see. So this is pending. That is fully correct now. So that means it has passed all the test cases that was available for this question. Okay, I hope that you have at least 50% to 60% you have clarity on both the question, and with time, with practice, you will definitely get through it. Last but not the least, please like this video, share this video, subscribe to Campus Monk, and do not forget to check the description box for the live classes and online courses that are currently there on the app, the platform. It will be of great help if you try to go there and spend some time. Right, I will see you in the next one. Until then, keep learning, and thank you.